Welcome to The Explainer. I am absolutely thrilled you're here today because we are tackling something that I know for a fact keeps a lot of ambitious math students awake at night. We're stepping into the flight deck of Cambridge AS and A-level mathematics, specifically zooming in on syllabus code 9709, topic 3.1 Algebra, modulus functions. Think of this explainer as your advanced aerial combat tactics for tackling the absolute toughest exam questions Cambridge can throw at you. We are flying at maximum altitude today. Now, you might be looking at this topic and thinking, come on, it's just absolute values. It just makes negative numbers positive. How hard can it really be? But here is the brutal reality check. The crucial difference between a solid B grade and a flawless, top-tier A-star grade almost always comes down to mastering the hidden, treacherous depths of modulus functions. Today, we are going to completely decode the exact anatomy of an A-star response, step by excruciating step. So, let me ask you this right out of the gate. What actually separates that B grade from an A-star in this specific topic? It's a provocative question, isn't it? To understand this, I want you to picture two types of students. Let's call our first student Alex. Now, Alex overloads their brain with raw mathematics facts. They memorize every formula, but there is absolutely no analysis. They see a modulus sign and they just blindly start squaring both sides without thinking. Then there's our second student, Sam. Sam is smart, but Sam rushes. Sam is constantly racing the clock, and because of that, Sam completely misses the specific command word requirements in the question prompt. Both Alex and Sam are going to get stuck at a B. Why? Because an A-star candidate moves completely beyond raw facts and rushed calculations into the realm of structured, tactical reasoning. They understand the underlying theoretical architecture of the math. They know exactly how the examiner is testing their cognitive domains. They don't just solve, they deconstruct. Here is our flight plan for today's session. 1. Core principles. 2. The methodology. 3. Examiner insights. And 4. The classic trap. Let's dive right in. Section 1. Core principles. The foundation of A-star reasoning. Listen closely, because before you write down a single equation, you absolutely must understand the theoretical foundation. Modulus functions aren't just isolated algebraic puzzles floating in a vacuum. They rest on a much broader conceptual framework. The principal examiner reports make this crystal clear. They note, and I quote, "Candidates referencing cross-topic connections achieve significantly higher marks. The examiners are telling us point blank that they heavily reward interconnected mathematical thinking." Think about Alex again. Alex tries to solve everything algebraically and gets lost in phantom roots. But if you're an A-star student solving an algebraic modulus equation, you immediately recognize how it links graphically to coordinate geometry or transformations. You are visualizing that classic V-shaped graph in your head before you even calculate the intercepts. You instantly cross-reference the algebra with a mental sketch. When you do that, your mark ceiling instantly lifts. You have to integrate this topic with other areas of the 9709 syllabus to truly fly at maximum altitude. To build those vital connections, you need to hit 3 precise academic benchmarks, which the syllabus calls cognitive domains. 1. Knowledge and understanding. 2. Application. And 3. Analysis. Knowing what the modulus lines mean, that's just step 1. That's knowledge. Applying that concept to a novel scenario, like an inequality, that's step 2. But analysis, that is where the A-star is truly won. Analysis means breaking down a multi-stage problem, evaluating alternative approaches, and deeply justifying your mathematical decisions. It means looking at the command words like hence, show that, or determine, and tailoring your exact mathematical approach to satisfy that specific command. You aren't just doing math, you are proving to the examiner that you understand the logic behind the math. Let's look at how this builds into our next core concept: analytical depth versus superficial breadth. A superficial approach, the kind Sam takes when rushing, is scattered. It's trying a bunch of different algebraic expansions blindly, hoping one magically yields the right roots. It's writing down everything you know about modulus and praying the examiner gives you a mark. The Cambridge assessment framework, however, prioritizes analytical depth. Logical, structured, evidence-based reasoning will always outscore a shallow, scattered approach. You need to show the examiner the why behind your what. If you reject a route because it doesn't fit the modulus constraint, you need the analytical depth to state exactly why that route is invalid.
Section 2. The methodology. Securing the method marks.
Okay, knowing the theory is great, but how do we actually translate that into hard marks on an exam paper? We need a bulletproof method mark strategy. Method marks are awarded for the systematic process, correct terminology, and logical reasoning, rather than just the final answer. The crucial takeaway here is that examiners want to see your procedural framework as much as, if not more than, your actual conclusion. If you make a tiny, silly arithmetic error on the final line, but your method was flawless, you are still walking away with the vast majority of the marks. Do not do the complex logic in your head. Put it on the paper. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Trust me, getting these strategies locked down is the best thing you can do for your grade. To secure those precious method marks consistently, you need a rigid system. You cannot just wing it. Here is the chronological deconstruct, solve, evaluate loop you should follow for complex modulus questions. Let's imagine you are facing a standard 5-minute question. Minute 1, deconstruct the question. Look at the command words. Is it solve algebraically or solve by sketching? Minute 2, extract the relevant data and break the problem into logical steps. Minute 3, select the appropriate analytical framework. Are you going to square both sides, or are you going to use the positive and negative case definitions? Minute 4, execute the analysis with clear systematic working. Minute 5, verify the results. This is where you check for reasonableness and plug those roots back into the original modulus equation to catch any phantom roots. This timeline is exactly how you should pace your thinking during the exam to avoid becoming a rushed student like Sam. Now, as you execute that problem-solving sequence, your presentation matters immensely. The source materials make it perfectly clear that the presentation of information follows strict conventions. You need proper headings, correct mathematical terminology, appropriate formats, and clear annotation. This isn't about having pretty calligraphy. It's about professional, clear mathematical communication. When you are asked to justify a step, I highly recommend using a structural framework like PEEL in your annotations. Point out what you are doing, provide the mathematical evidence, explain why it's valid given the modulus constraint, and link it back to the question. When you annotate your algebraic steps clearly, you are actively grabbing the examiner by the hand and guiding their eye to give you those method marks. Section 3. Examiner Insights. Avoiding the pitfalls. The principal examiner reports have repeatedly identified 3 critical, widespread mistakes when it comes to modulus functions. If you can avoid these 3 specific things, you are instantly ahead of 80% of the candidates. Let's break down these top 3 mistakes. Mistake number 1, using the wrong approach for the specific context. Remember, higher-order objectives demand that you evaluate alternatives. Sometimes, squaring both sides of a modulus inequality is the absolute most efficient path. But other times, squaring introduces a nightmare of a corked equation and phantom roots, whereas sketching a quick V-graph would solve it in 30 seconds. Picking the wrong approach leads to an algebraic mess. Mistake 2, forgetting to check format and presentation. Rushing leads to dropped negative signs, flipped inequality symbols when dividing by a negative, or lost annotations. And mistake 3, which is a massive one, generic answers that are not specific to the given context. This is where your multi-stage analysis completely falls apart. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Take a look at this table. It serves as a brilliant mental cheat sheet to evaluate your own working, exactly like an examiner does. I want you to mentally apply this right now. When you are looking at your algebraic evidence or your logical steps, ask yourself, what is the limitation here? For example, if I squared both sides, the limitation is that I might have created false solutions. What assumption have I made? I assumed both sides were positive. And what is the effect on my conclusion? The effect is that I must test every single root in the original equation before finalizing my answer. Top-scoring A-star candidates demonstrate evaluative thinking by constantly, aggressively questioning their own assumptions. They justify their decisions. If you discard a negative root because of the modulus context, don't just cross it out. Clearly state why you did it. Section 4. The Classic Trap. Examiner Alert. The sources issue a massive, blinking red examiner alert about this next point. The absolute classic mistake is providing generic answers versus context-specific answers. Let's say a modulus function in your 9709 paper models a real-world scenario. Maybe it's representing a physical tolerance of a manufactured part or a velocity boundary in a related mechanics context. If you just give a generic algebraic solution like x equals 5 or x equals -5 without interpreting what that actually means for that specific scenario, you are going to bleed marks. The examiner is checking your command word compliance. A generic answer completely loses. An answer that is locked entirely into the given scenario wins the day. So, the golden rule, the one massive takeaway you must remember from this entire explainer is this: always link every single point to the given scenario. Don't just find x and move on. Explain what x means in the context of the problem. If it's a coordinate geometry crossover, state that the roots represent the exact points of intersection between the line and the v-graph. Show the examiner that you have that top-level cognitive domain of application and analysis fully 100% engaged. We have covered a lot of ground today. We've hit the core principles, the method mark strategy, the top mistakes, and the classic trap. Now the ball is entirely in your court. I want to leave you with this question. How will you implement the deconstruct, solve, evaluate framework in your very next past paper? Next time you sit down to study, don't just solve blindly for the answer like Alex, and don't rush the command words like Sam. Deconstruct the question, pace yourself through the 5-minute loop, annotate your logic, and link your final answer back to the context. That is the true anatomy of an A-star. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. Keep questioning those assumptions, and I'll see you in the next strategy session.